Welcome to This Explainer. Okay, let's just dive right in and shatter the romantic myth of the lone genius inventor. You know the one. We hear the name Thomas Edison, and we're culturally conditioned to picture this solitary wizard having a magical, spontaneous eureka moment under a glowing light bulb in the dead of night. But actually, that image is a complete fabrication. The historical reality of invention is far more analytical, incredibly systematic, and frankly, a whole lot more industrial. Today, we're looking at how Edison didn't just invent physical products, he quite literally invented the very process of modern research and development. We're going to see exactly how he built the machine that makes the machines.
Now, you've definitely heard the famous quote, 1% inspiration and 99% perspiration. But Edison didn't just say this to be catchy or motivational. No, this was his literal foundational business model. For Edison, innovation wasn't a sudden strike of lightning. It was a grueling, highly organized, data-driven slog that required massive systems and relentless, heavily resourced trial and error. He built an empire around the idea that if you just throw enough structured labor at a problem, you can essentially manufacture inspiration on a highly predictable schedule.
To really unpack how he pulled this off, we're going to break this down into 5 parts. Beyond the lone genius, the Menlo Park blueprint, inventing the system, scaling the innovation engine, and finally, the modern R&D legacy.
Starting off with Section 1, Beyond the Lone Genius, Dismantling the Wizard Myth.
So historically, invention was seen as this solitary, almost artistic pursuit. You had passionate individuals tinkering away in a garage or an attic, just waiting until that magical eureka moment hits. That is the myth we've all been sold, right? But the reality is that Edison operated much more like a modern, hard-nosed innovation executive. He basically took the romance out of it and replaced it with a relentless, data-driven factory model. It was completely revolutionary at the time to grab a classically trained chemist, put them right next to a gritty machinist and a theoretical engineer, and tell them, hey, figure out how to make this concept profitable. He demanded cross-disciplinary teamwork and kept a strictly commercial focus. Literally, if an idea couldn't be efficiently manufactured, sold, and scaled to the masses, he simply wasn't interested in spending another minute on it. 1,093. That is the staggering number of U.S. patents registered in Thomas Edison's name. Let that sink in for a second. You simply cannot reach that astronomical level of intellectual property generation by just tinkering alone in a workshop on the weekends. I mean, it's a physical and intellectual impossibility. Achieving that kind of output requires a machine. It requires a finely tuned engine of skilled workers, draftsmen, and researchers constantly iterating, testing, and filing paperwork under a centralized, commanding strategy. This number right here is the ultimate proof of the absolute brute force efficiency of his industrial approach.
All right, moving on to Section 2, the Menlo Park blueprint, the first industrial laboratory.
So Edison essentially invented the modern concept of corporate R&D. With the massive funds he got from his early, highly successful telegraph inventions, he didn't just buy himself a nicer personal workshop. Instead, in 1876, he created a dedicated, sprawling facility in Menlo Park, New Jersey. Its entire purpose was applying the strict principles of organized science and coordinated teamwork to create new knowledge, and, crucially, to rigidly control its commercial application. This was a radical departure from the old model of academia, where science was just kind of done for the sake of science. Edison fused the scientific method with capitalism. He built a facility designed to just churn out profitable utility, effectively turning the totally unpredictable art of discovery into a highly predictable corporate asset. To give you an idea of how this operated, he stockpiled 8,000 kinds of chemicals, every conceivable size of needle and wire, and yes, even hair from humans, hogs, and horses, along with shark's teeth and various animal hoofs. I know, it sounds like a witch's brew. But the logic here was incredibly calculated. I mean, why stockpile tortoise shells and amber? Because friction is the absolute enemy of rapid innovation. If a researcher hit a roadblock and needed to test a highly specific material for a microphone diaphragm or a light bulb filament, they shouldn't have to completely halt their momentum and wait 3 weeks to order it from a specialized supplier. Having absolutely everything on hand in this exhaustive inventory eliminated friction and allowed his teams to engage in continuous, rapid-fire prototyping without losing their creative rhythm. But of course, this massive operation required intense human labor. It's the very literal definition of his 99% perspiration philosophy in action. You can see his pretty brutal expectations laid out clearly here. Employees worked Monday through Friday, plus weekends. Shifts routinely ran 18 hours per day. Actually, one employee famously described the environment as pushing the limits of human exhaustion. So the industrial lab wasn't just about throwing limitless physical resources at a problem. It was about intense, heavily concentrated human labor driving forcefully toward patentable, profitable outcomes. Edison demanded total dedication, essentially running a high-stakes tech startup over a century before Silicon Valley even existed. Let's dive into Section 3, Inventing the System Beyond the Glass Bulb. Edison deeply understood something that was way ahead of his time. A singular product is entirely useless without an ecosystem to support it. Think about it. An incandescent glass bulb doesn't do you any good if there's no electricity flowing into your house to turn it on, right? So step one of his strategy was, of course, the bulb itself, where his team exhaustively tested thousands of materials before finally settling on a durable, carbonized bamboo filament. But step two required him to essentially invent the entire utility industry. He had to design massive mechanical electric generators and engineer completely new three-prong wires for 110-volt direct current distribution just to safely move power from a central station into residential homes. And finally, step three, monetization. How do you actually make it a viable business? Well, he deployed customized zinc plate meters to physically measure exactly how much current customers were drawing so he could accurately bill them. He didn't just invent a light bulb, he engineered a completely new urban ecosystem. And because of this highly integrated, systematic machine he built, the timeline from a raw lab prototype to a fully scaled public utility moved at absolutely breakneck speed. Just look at this pacing. He officially announces the audacious goal in 1878. Just 1 year later, by 1879, he secures the patent for the carbon filament lamp. By 1880, he's already executing the first commercial installation aboard the steamship Columbia. And by 1882, the Pearl Street Station is switched on, powering over 500 customers right in the middle of Manhattan. Moving from a conceptual idea to a functioning urban infrastructure in just 4 years was completely unprecedented, and it was only possible because of his deeply organized R&D framework. Okay, Section 4, Scaling the Innovation Engine, Automation and Growth. So Menlo Park was absolutely foundational. It birthed legendary technologies like the phonograph and the practical light bulb, all within the footprint of just 2 city blocks. But by 1887, that wasn't nearly big enough for Edison's ambitions. He needed to go bigger. So he built the West Orange complex, which was more than 10 times the size of his original facility. He wasn't just scaling up a single product line anymore. He was scaling the very act of invention itself. He centralized a massive, highly specialized workforce here, so his organization could attack multiple massive industries simultaneously, all in parallel. Whether his teams were pioneering early motion pictures, developing advanced storage batteries, or completely rethinking heavy mining, West Orange was designed to be an unstoppable engine of global innovation. For example, when Edison turned his sights to mining low-grade iron ore, he brought this exact same relentless systems-level thinking with him. He wanted to remove manual human labor entirely. To do this, he implemented massive 70-ton electrically powered rollers to crush rock. He built vast networks of gravity-fed conveyor belts and utilized an astonishing array of 480 electromagnets for automated mineral separation. His ultimate, incredibly modern goal was zero human touch from the moment the raw rock entered the facility to the moment the finished iron briquette left it. Now, what makes this fascinating historically is that this specific mining venture actually lost millions of dollars. But it's a perfect example of his methodology. He treated the factory itself as a giant machine, proving that his analytical systems approach could be applied to virtually any heavy industry. 10,000 combinations. When Edison decided his company needed to build a highly durable, rechargeable battery for early electric automobiles, there was absolutely no guesswork involved. His laboratory team methodically, exhaustively worked through 10,000 different permutations of materials. They tested endless variations of electrodes and chemical solutions until they found the precise alkaline nickel-iron combination that met his extraordinarily strict commercial standards. This wasn't a sudden spark of genius. It was pure brute force, data-driven scaling. It was the absolute embodiment of using perspiration to guarantee inspiration. And that brings us to our final section, Section 5, the modern R&D legacy, the blueprint for today. Because here's the thing, Edison's playbook from the 1880s is the exact same playbook running the global tech industry today. Take a close look at these comparisons. Edison purposefully built massive patent portfolios to aggressively and legally protect his technological advancements. Today, modern tech giants do the exact same thing, calling them intellectual property moats. Edison pioneered the concept of team-based, organized science at his Menlo Park and West Orange facilities. Today, we refer to these as cross-functional product teams, blending engineering, design, and marketing into one unit. And Edison's brilliant integration of the light bulb, the generator, and the billing meter, that is the exact same strategic philosophy behind the tightly integrated closed ecosystems developed by companies like Apple or Google today. They control the hardware, the software, and the marketplace. Edison literally laid the operational tracks that our modern digital economy is running on.
So I'll leave you with this final thought. Is today's global tech industry really just Menlo Park operating on a larger scale? Every single time you use a seamlessly integrated tech product today, whether it's your smartphone or your electric vehicle, you are directly experiencing the legacy of Edison's invention factory. It was never about a lone genius waiting for a light bulb to magically turn on above his head. It was about relentless, data-driven, highly organized perspiration. Thank you so much for joining me for this explainer. Keep learning and always keep looking for the complex systems operating behind the seamless innovations in your everyday life.